Well, as we finish up our week and head off into the week of Thanksgiving, one of the things you can be thankful for is that this is going to be the shortest notes that you have all year. It's only one example long, so you can be grateful for that right now. We're going to keep working with implicitly defined functions, and we're going to look at tangent and normal lines. All right, so again, here is an implicit equation. And so we need to understand what is implicit about it, what is implied. So like we talked about yesterday, there are implied set of parentheses around the x squared. There's an implied multiplication between x and y, and then there's another implied set of parentheses around the y squared. So that impacts how we're going to take our derivative. All right, so we'll pull the 2 to the front. That gives me 2 parentheses x. And then I need the chain rule on the inside, which would be dx over dx. Then minus, and as I get ready for this minus, I'm going to need the product rule. So I'm going to set up my product rule with my 4 parentheses. However, because of the minus, I need to surround my product rule with a large set of parentheses. And that one step is the most commonly missed, one of the most commonly missed steps for AP students and regular students alike. And so just be cautious whenever you have a product rule with a constant in front or a minus sign in front that you need that extra set of parentheses. Okay, now we're ready to start filling in our product rule. So we'll have y first, and then the derivative of x, which is dx over dx, and then x, and then the derivative of y, so dy dx. Okay, plus, now we're ready for the 2 to get pulled in front, so we'll have 2 pulled in front of y, which is in the implied parentheses, and then multiplied by the chain rule for that. And then finally, we'll have on the equal sign, on the other side of the equal sign, we'll have the derivative of 7, which is 0. Okay, a couple things we want to do here. We want to reduce dx over dx, and we'll do that twice. And we also want to distribute the negative sign. Okay, so remember I talked about how important that was and I highlighted those parentheses? That negative gets distributed. So let's see what we have left. We have 2x. We have minus just y, because the dx over reduced. And then minus x dy dx. And then 2y dy dx being equal to 0. So we have 2 dy dx terms left, and so we want to subtract 2x from both sides, and we want to add y to both sides. So that will give me negative x times dy dx plus 2y times dy dx. On the other side, I'm going to write y first because it's positive, and then minus 2x. So now as a GCF, I can take out dy dx because it's in common to both of those. And we're going to get negative x plus 2y. And then we'll use division to solve for dy dx. So it'll be y minus 2x in the numerator divided by, and I think I'm going to put the positive part first again, so 2y minus x in the denominator. Nothing reduces here. Can't reduce the 2's, I can't reduce the x's, I can't reduce the minus signs, I can't reduce the y's. This is subtraction problems, and there is no reducing in subtraction. But now I want to find the slope. And to find the slope, I'm going to plug the point value that we were originally given. So I'm going to plug negative 1 and 2 in for x and y. So that'll be 2 minus 2 times negative 1 over 2 times 2 minus negative 1. All right, so the slope turns out to be 2 plus 2 in the numerator, and then 2 plus 1, so 4 plus 1, so 4 over 5. Okay, now we're ready to answer the question. The question is, find the tangent line and the normal line. So remember, for the tangent line, we just need a point and a slope. So the point is negative 1, 2, and the slope we just found is the slope 4/5. So the tangent line will be y minus 2, 4/5 for the slope, x plus 1. And then I also want you to find the normal line. And so the point is still the same. The point is still negative 1, 2. But the normal slope has now changed to negative 5/4. And so my normal line is y minus 2, negative 5 over 4, x plus 1. Okay, so I promised it would be short. It's under 7 minutes, so I think that's a record. So I hope that you were able to work through some of your questions on implicit differentiation from yesterday, and now you'll work on 3.2b. Sign up for a time slot on Friday if the chain rule or implicit differentiation, if any of that is giving you trouble. Let's take care of that on Friday and we'll work on it together. All right, I hope you have, if I don't see you, I hope you have a great Thanksgiving holiday, and know that my job here at Valley Christian and the students, you guys that I get to work with, are some of the things that I am the most thankful for. All right, God bless you and have a good weekend.